Hi, welcome to Dissolve Chemistry. Let us continue our discussion with Mission 70. So, in the previous video, we have discussed various concepts in solutions. Okay, entire chapter we have covered in 1 hour 15 minutes. Please go through that video prior to watching for this. And this video is exclusively meant for numerical problems. Okay, already we have discussed and we found that solutions carries total 13 marks weightage is there. In that 1 mark, 2 questions will be there, 1 mark, and then 2 mark question, 1 question will appear. Okay, and it will be theory part only, and another one will be 3 mark question, that is also theory. Okay, and 3 mark question, 2 numerical problems will be there. Okay, and among those 2 numerical problems, see, as we see the earlier trends from since 2014, so they used to ask one numerical problem from the solutions, and that numerical problem used to be on the colligative properties. Okay, all the papers will have the same colligative properties is being included as a numerical problem. So now, of course, now also we will be having one numerical problem on colligative property, which is very important. Only 3 formulas, if you remember, you can solve the problems. Okay, numerical problem on this colligative property. And another numerical problem. So now, from where do they ask? That question rises. Maybe they may ask on, first one is expression of the concentration of the solutions, molarity, molality, percentage mass. Okay, expression of concentration, on that they may ask, or they may ask on Henry's law, or they may ask on Raoults law. Okay, these are the 3 possibilities from which you will get one numerical problem, and usually high order thinking problem will be on this. It is given in the blueprint that HOTS. Okay, HOT means high order thinking, and such problem may arrive on this particular topic, that is expression of the concentration, Henry's law, Raoults law. Okay, and one numerical problem, very easy problem, that will appear on the colligative properties. Okay, so therefore you be prepared for both numerical problems. Okay, and here I am expecting to take 20 problems. In that 10 problems I will cover from this. Okay, so that is expression of the concentration, Henry's law and Raoults law, and another 10 problems I will take previous year questions. Okay, so that is on colligative properties, right, including Vent-Off factor. That is also one of the important one. Okay, Vent-Off factor, so that also comes in colligative property only. On that also there is a possibility of a question arriving on that particular topic, right? So, well, let us start with first we will see on the concentration numerical problems, and prior to going for that, so let us recap the formulas what we come across in this numerical problems, right? Well, in the expression of the concentration, right, so you will be having problems on percentage composition. Okay, so please watch our previous video on solutions, where in that video we have covered all the theory aspects, including these formulas, derivation and all that things. Okay, so please go through that also. Percentage composition. So in that percentage composition, of course, weight by weight they may ask, right? Weight by volume. Okay, so whatever may they ask on these formulas, the general formula I will write. So it will be weight or volume, okay, of solute divided by total weight of solution. Weight or volume means I am including all the definitions: weight by weight, weight by volume, volume by volume. Okay, so for that only one single formula I am making, into 100%. Okay, in solving numerical problems we will go in detail with these things wherever we come across with, right? So fine, this is the one formula where percentage composition they will ask. and followed by that they may ask about molality. What is the definition of molality? Number of moles of solute by what? Weight of the solution in kilograms. Okay, kg. Right? Per kg we call. Moles per kg. Moles per kg. Similarly, molarity. So it is nothing but number of moles of solute to the volume of the solution in terms of liter, moles per liter. Okay, so like that, molarity, and followed by that, you may get the questions on, you can take molality, parts per million. Okay, so on that also you will be getting parts per million. Very dilute solution we are going to express in terms of parts per million. One problem we will take on this also. Okay, parts per million. Here what they will do, they, for example, 5.8 ppm. So they will ask you to express this in terms of concentration, in terms of molality or molarity, or even in terms of percentage composition. We will see the problems. We will understand that one. Okay. So like that, the question will appear on parts per million, right? So then mole fraction is there, very important. So on that mole fraction also you will be getting problems, and mole fraction is equal to number of moles of solute divided by total number of moles of solute plus solvent. Okay. So this formula you should remember. And this is all about expression of the concentration. We are expecting problem on this. Problems on this Henry's law. Okay. We know that the partial pressure of the gas over the surface of the solution is directly proportional to what? Mole fraction of that gas in the given liquid. So that is how we are going to get mole fraction of the solute. A you can take, right? So where it is Henry's constant, you should remember this formula. This is the partial pressure of the gas, and this is the mole fraction of the compound in that. We will see the problem on this, right? Apart from this, the next important is Raoults law. Okay, so on the Raoults law, you will be getting questions on this partial pressure of any component, liquid component of the solution is equal to the pressure of the gas or pressure of the vapor in the pure state into its mole fraction. So this is the formula what we are going to use in solving the problems. Okay, one or two problems we will take on this also, right? So these are the important formulas that you have to remember to solve one numerical problem. And another part is, I have divided that into two parts. One part, expression of the concentration, Raoults law, Henry's law. So on that you will get one numerical problem. And another part is your colligative property. Compulsory one question will be there from that also. Okay. So therefore, first part we will see, okay, on this Henry's law, expression of the concentration, and Raoults law. The problems we will solve first, and followed by that we will go to the colligative properties. Okay. So we'll see that one. First problem is calculate the mass percentage of aspirin. Its molecular formula is given C9H8O4. Okay, in acetonitrile, its molecular formula is CH3CN. When 6.5 gram of aspirin is dissolved in 450 gram of acetonitrile. Okay, you should read the question carefully. What it is being asked, mass percentage. Okay, so already what they have given, the mass of the aspirin is given, and mass of the acetonitrile is given. So therefore, percentage mass is equal to, formula we will make, right? So first you should write the given quantities, right? Always remember, when the problem is given, you should write the given quantities. It carries the marks, and followed by that you should write the respective formula. So that also carries the mark. And lastly, for answer, okay, you should solve. You should put the values, and if you solve the problem properly, and if you write the correct answer, so then you will get another marks. Okay, 3 marks will be divided into slabs will be there. Okay, 1 mark for given quantities with formula. Then whatever you put in the formula for that 1 mark and answer 1 mark. So like that they are going to divide. So therefore you must write the given quantities. So what is given? Mass, say for example, weight of aspirin. We will take W1 as 6.5 gram. Okay. Similarly, the weight of acetonitrile solvent is given, that is 450 grams, right? And what they are asking, just calculate the mass percentage they have asked. And mass percentage formula you should write like this: percentage of mass is equal to, okay, so weight of the compound, so that is W1 divided by total weight of the solution, that is W1 plus W2, okay, so into 100%. Okay, so like this you should write the formula and then substitute the values in the formula. So mass percentage is equal to W1 is 6.5 divided by 450 plus how much? 6.5 means total weight of the solution, weight of the component of which you want to check the mass percentage divided by total mass of the solution. Okay, so that you should remember. That is what is the formula. So into 100%, right? So just if you simplify, you will be getting the answer for this. That we call it as what? Percentage of mass. 1.42%. Okay, the amount of aspirin in the given solution is 1.42%. Please solve this problem, right? So if you do this much, so you will be getting 3 marks. Okay, so make sure that, so what formula you have to apply, and you should write the given quantities. Then you will get an idea that what formula I have to apply and how we will get the answer, right? We'll take to the next problem. This second problem, nalorphine. Okay, C19H21NO3, similar to morphine, is used to combat withdrawal symptoms in narcotics user. Okay, dose of morphine, okay, generally given is 1.5 milligram. Calculate the mass of 1.5 into 10 to the power minus 3 molal aqueous solution required for above dose. Okay, so like this they will ask. This is comes under HOTS, means high order thinking. Okay, so they will give like applied type of question is there, right? So whatever it is, don't go through in the wordings of the problem. Okay, so what they have given and what you are supposed to calculate, only you focus on that particular aspect, right? So we'll see the solution, what it is. First thing I told you, what you have to do, you have to write the given quantities. Okay, so the dose, the amount of the substance that you take it as W1 is equal to 1.5 milligrams, right? Then they want to give that as an aqueous solution, right? So therefore they are making it as molality of the solution is given, molality, okay, 1.5 into 10 to the power minus 3, okay, mole per kg. Okay, introduce 1.5 milligrams in terms of aqueous what solution, right? So it is given as a aqueous solution, dose is given. So therefore you have to check that how much we have to take to give this much amount of the drug. Okay, so that we will do as, see here, first thing what you have to do, 1.5 milligram means it corresponds to how much molar mass. Okay, so to do that, so to check its number of moles corresponding to these many grams, so what you have to do, you have to calculate the molar mass of nalorphine. Okay, so molar mass, how we will calculate, see here, 12 into 19, it is atomic mass of carbon, right? So carbon 19 are there, so therefore into 19 you do. So then next is hydrogen. We know that 21 1 into 21. So then nitrogen 1 into 14, and oxygen, so how much it is? 3 into 16. So therefore you will be getting, these are all atomic weights. Okay, so and this is the number of atoms present in the given molecule. So therefore we can do what? This is how we can calculate the molecular weight. So you do this, you will be getting 228 plus 21 plus 14 plus 36 into 3, 8. Okay, 48 you will be having. 311 is the molar mass of your referee, right? So next is, so molality is equal to what we know that, so number of moles divided by weight of the solution, that should be expressed in terms of 1000. Okay, so we will multiply like this with 1000, right? So number of moles, how we will calculate? 15 into 10 to the power minus 3. 1.5 milligram is there, so therefore we will make it in terms of grams. So therefore 1.5 into 10 to the power minus 3 grams divided by how much will be? 311, right? Into, so that you are supposed to calculate W2, weight of the solution, right? Divided. So this is 1000 you write above it. You will take into like this, right? So then what you do, already here it is given 1.5 into 10 to the power minus 3, right? You take on to that side and W2 will come over here. So then you will be getting W2 is equal to 1.5 into 10 to the power minus 3, okay, into 1000 divided by 311, okay, into 1.5 into 10 to the power minus 3, because we have expressed that in terms of what? Grams, and it is already the molality what it is being given. Okay, you put the formula. So then what happens? You will be getting like this if you cancel it. So then you will be getting 1000 divided by 311. Expected to introduce 3.21. So this much solution if you introduce, so then what happens? That corresponds to 1.5 milligram. Okay, so this is how you are supposed to solve the problem. If the molecular formula is given somewhere, there is an expectation to calculate the molar mass. If required, you can do that one. Okay, next we will move on to the third problem. Well, the problem is to calculate the amount of benzoic acid required for preparing 250 ml of 0.15 molar solution in methanol. Okay, so I will give simple methodology for this. Okay, they want to make 250 ml solution, right? And the concentration is 0.15. It is also required concentration, we say that. Okay, so 0.15 molar 250 ml solution we want to prepare. Okay, so simple, we will understand that. So in methanol we are preparing. See, try to understand this one. So always remember, molarity means 1 liter of solution, 1 mole per 1 liter. So then it is called molarity. 1 mole per, or mole, number of moles per liter. So 1 mole of the substance means how much, that we have to calculate. For that again we need what? Molar mass of benzoic acid. Sometimes they may give in the examination molar mass. If it is not given, simple, because if it is an organic molecule, you will be having carbon, hydrogen, oxygen and nitrogen. Okay, and all these atomic weights, you should be aware of that. Okay, sometimes if they won't give, then you should be in position to calculate that one, right? So there are 7 carbon atoms, 7 into 12, then 6 hydrogen atoms, 6 into 1, and then 2 oxygen atoms into 16. Okay, you just calculate this, it will be 122 is the molar mass of what? Benzoic acid. So now we will do the calculation. See here, first we will write amount of benzoic acid per mole. How much it is? 122 grams. Fine. Now same if you dissolve it in 1 liter volume. Suppose if you are dissolving that in 1000 ml. Okay. So then your molarity of the solution will be what? 1 molar we call. Right. So now suppose if you want, right, how many volume we want to change. So therefore volume, how much required volume is what? 250 ml. So therefore what you do when you are changing this, then what happens? You have to divide this. Okay. So by 4, and this also you divide by 4. Right. So then what happens? It will turn out to be, so 250 ml you will get, and here if you divide this, okay, so you will be having 4.5. Okay, so you will be getting 4.5 grams. If you dissolve in 250 ml, you will be getting molarity as 1 molar. But required molarity is how much? So the required molarity is 0.15 mole. So for that, what you have to do is 1 mole corresponds to 1 mole 250 ml corresponds to how many grams? 4.5 grams. Right? So therefore, same 0.15 mole corresponds to how much? 0.15 into 4.5 gram divided by what? 1 mole. 0.675 grams of benzoic acid is required to prepare this molarity 250 ml solution. Okay, so this is how lastly you have to write 0.675 grams of benzoic acid. It has to be taken to prepare 250 ml of 0.015 molar solution. 250 ml. Right. So that is how we can solve this problem. Right. So next we will move on to the next problem. A sample of drinking water was found to be severely contaminated with chloroform and supposed to be carcinogen. The level of contamination was 15 ppm. When the concentration is too low, then we are expressing in terms of ppm by mass. Okay, so then they are asking you to express this in terms of percentage of mass, as already I have said initially. And the second one is determine the molality of the chloroform in the given water sample, right? So let us solve this. They may ask one part or maybe two parts. Okay, let us be ready with both. Okay, we will solve both. Sometimes they will ask only percentage mass, by mass you have to calculate, or you have to calculate only molality, they may ask, right? Or sometimes both they will ask. So solution, the first thing is the given quantity is what? The concentration of the solution in terms of what? ppm it is given. 15 ppm of chloroform is present. Chloroform, right? So then you are expected to express the same in terms of what? First one is you are expected to express in terms of percentage by mass. Okay. So what do you mean by this 15 ppm? 15 ppm means 15 parts. Okay, by mass he is saying. So therefore 15 grams in 10 to the power 6 grams. Okay, per 10 to the power 6 there is 15 grams, like that we can say in terms of mass what it is being given, that meaning. But now what we want? So 10 to the power 6 gram corresponds to 15 grams. Okay, we will write like this. And he is asking percentage mass. So therefore percentage means what? 100. Per 100 how much it is? Per 10 to the power 6, 15. So then per 100 how much it is? So that is what is the meaning of this question. So therefore that we will solve. So 100 into 15 gram divided by 10 to the power 6. Okay. So therefore what we can make? So if you take on to the top, so what it will be? So 100 into 15 into 10 to the power minus 6. 10 to the power minus 600 means it comes out to be what? 15 into 10 to the power minus 4. Okay, grams, gram percentage we can say. So in terms of percent we can say, right? So that is what we express in terms of percentage. 15 into 10 to the power minus 4 percent we call, right? Next part, second part is they are asking about molality. We know that what is molality. So that is number of moles, okay, per kg of solvent, right? So therefore, to do that, what you have to do, you have to know the molar mass of the chloroform. As it is not given, we will calculate that one. Okay, again you should know that one. C12, hydrogen 1, and your chlorine is 35.5. Into 3 we have to do, because CHCl3 is the formula of chloroform, right? So 106.5 plus 12 plus 1.5. So this 3, 1. So it comes around 113.5. 15 into 10 to the power minus 4 per 100 gram it is. Okay, weight of the solvent will be per 100 gram. So therefore that if you want to express into 100, okay, so above you have to take 1000. Why you have to take 1000? Because we are expected to express answer in terms of kg. So therefore 1 kg means what? Already only 100 gram it is given. So 100 gram per 100 gram, this is the concentration. So therefore per 1000 how much it is? So that is what we have taken. So therefore it turns out to be 1000. If you multiply means 15 into 10 to the power minus 1. Okay, so divided by 113.5 into 100. If you take on to the top, it will be 10 to the power minus 2. So therefore 15 into 10 to the power minus 3 divided by 113.5 comes around 1.32 into 10 to the power minus 4 mole per kg of the solvent. Okay, so that is the molality of what? Chloroform in the given solution. Okay, so this is how we are expected to solve. And if you do this much, sometimes they may ask only this particular part, or they may ask about this particular part, or both may be asked, and probability is only one part they will ask, right? So, okay, an antifreeze solution prepared from what? 212.6 gram of ethylene glycol, that is C2H6O2, and 200 gram of water. Then you calculate molality of the solution is being asked. Okay, what you are supposed to do is that write the given quantities. So weight of the solute, here solute is water, you should remember, because already we have defined what is solute, what is solvent. Which is in less quantity, that is considered as a solute, which is in more large quantity, that is considered as solvent. So therefore here solute is your water and your solvent is your ethylene glycol, and from which they have prepared antifreeze solution. Okay, so now they are asking about its molality. Okay, so therefore molality is equal to, what is the formula? Molality is equal to number of moles of solute divided by weight of the solvent in kg. Okay, so therefore we can write like this, W1 by molar mass of that, okay, divided by W2, okay, divided by 1000, because it is given, if it is given in terms of grams, if you want to convert that in terms of kg, so you have to divide that by 1000. So therefore molality is equal to, so what you will be getting, W1 weight of the water is 200 grams. Okay, molar mass of water is 18. You can calculate H2O 2 plus 16. So that turns out to be 18 grams. So 18 grams, 1000 will come up. So we will write 1000 here divided by W2 is how much? So 222.6. So therefore molality is equal to, just if you solve, you will be getting the answer, right? 200 divided by, you have to write the unit gram per kg. Okay, so that is what units are very important. That also carries the marks. Okay, so this is how you can solve the problem, right? So this is how they may ask about molality. Even they can ask about molarity by giving density. Okay, so then you are expected to solve like this. Fine. So we will move on to the next problem. Okay, we will take another problem on this molality. See here, if the density of some lake water is 1.25 gram per ml and contains 92 gram of sodium ions per kg of water, calculate the molality of the Na plus ions in the lake water. Okay, so the lake water comprises these many grams of sodium ions per kg of solvent, and density is given. If it is required, we will use it, otherwise no need to take that into account, right? So given quantities you write. So weight of the solute W1 is equal to 92 gram per kg of solvent, already they have given, and density they have given. I don't think this density is useful for you, just to confuse they have given this, right? So then we know that what is the formula for molality. Already we have written molality, small m is equal to number of moles of solute divided by weight of the solvent in terms of grams, right? Sorry, kilograms, kg. So now number of moles of solute means what you have to do is weight of the solute divided by its molar mass divided by weight of the solvent. Already it is given in terms of kg, no need to divide that by 1000. Okay, as we have done in the previous example, right? So weight of the substance is 92 and atomic mass of sodium ion is how much? 23 into 1 by W2 is how much? Already it is given 1 kg. You write like this, 1 kg. So molality is equal to 4 mole per kg. Okay, so that is how molality of Na plus ions in the lake water. You should write like this, lake water. And please remember, you should write the unit, otherwise your answer will not be considered. Fine. Next, we will move on to the next problem, seventh problem we will take. So next, again, a very interesting problem that the solution is given in terms of weight by weight percentage. Already they have given, and what would be the molality and mole fraction component in the solution, and then if the density is given, then molarity. Means three things are being asked. One is molality, another one is mole fraction, and then another one is molarity. Okay, so and they have given, okay, you should write, given molecular weight of glucose is 180. Okay, they will give, right? No need to worry. 180 is the molecular weight of the glucose. So let us solve this, right? So 3-mark question. Molality, if you calculate, you will get 1 mark. Mole fraction 1 mark, and molarity another mark. So we will see that one. So we will divide this, right? What you have to do, first one is molality we will do. Already we know that what is molality. Small m is equal to number of moles, okay, per what? Weight of the solvent. Is it clear? So already number of moles means what you have to do, 10 divided by 180 you have to take, because molecular weight of glucose is 180 and weight of the glucose here it is 10 grams per, okay. So then weight of the solvent will be what? 90%. 10% means, you should remember, 10% means it implies that your glucose is how much? 10 grams, and your water is how much? 90 grams. Okay, so therefore we can solve this problem. Molality is equal to what you have to write? 10 divided by 180 into 1000, because the quantity of the solution is given is 90 gram, but we want in terms of kg, so therefore we have to multiply that with 1000 into 90 you take. Okay, so this 0 will go, this 0 will go, so therefore how much you will be having? 100 divided by 18 into 9. So small m is equal to 0.617. Okay, so that is how we will get molality. Then next we will move on to, next is percentage, mole fraction they have asked. Mole fraction, second one is mole fraction. So in that mole fraction means already we know that formula n divided by n plus n. So that we equal to as what? Mole fraction x we can take. Mole fraction of glucose corresponds to n divided by n plus n. That is nothing but what? Total number of moles of solute. Okay, that is 10 divided by 180, right, divided by 10 divided by 180 plus solvent is how much? 90 divided by 18. Okay, if you simplify this, so the answer what you get, 0.018 is the mole fraction of glucose in the given solution. Okay, so the third part of this question is molarity they have asked. Molarity is equal to number of moles by the volume of the solution in terms of liters. Okay, and volume of the solution they have not given. Okay, so weight by volume, that is grams. In terms of grams they have given, that we have to convert it into what? In terms of ml. So to do that we have to take the help of density. Okay, so for that reason it is given. Density is equal to mass by volume. Okay, so therefore volume is equal to what we will be getting? Mass by density. Now what you do, you substitute mass is 90 gram. Okay, divided by density is how much? 1.2. So if you divide, so then you will be getting the volume. It comes around 75 ml. Okay. So now what you have to do? Molarity, capital M is equal to number of moles. Okay. So already we have checked that number of moles means 10 divided by 0.055. Here we have calculated 10 divided by 1 by 8. So that is 0.055 divided by 75 into 1000 we have to do, because we have to express the concentration in terms per liter, not in terms of ml. Okay, so therefore we have to multiply that with 1000. So there 0.73. Okay, so this is how we are calculating, and unit you should write gram per liter, and here it is gram per, sorry, mole per, not gram, you should write mole. Mole per liter. Here it is again mole per kg of solvent, right? Mole fraction, there is no unit, so therefore no need to write the unit for this, right? So that is how you have to solve this problem. Problem is on again Raoults law. Okay, the problem is the partial pressure of ethane over a solution containing 6.56 into 10 to the power minus 3 grams of ethane is 1 bar. If the solution, okay, if the solution contains 5.00 into 10 to the power minus 2 grams of ethane, then what shall be the partial pressure of ethane? So that is the problem what they have been asked. Okay, so now how to approach this? We know that from Raoults law. So they have given the amount of the substance, the partial pressure. Okay, PA is equal to P naught A into XA. We know that one. Okay, so this is what how we give. So this is the vapor pressure of the component in the pure state. Okay, and this is what is the partial pressure. Okay, and we know that so XA, right, will be what? Mole fraction. And we know one fraction we will take, and we know its partial pressure. Then we will calculate this in the pure state how much it used to be. So then what happens? From that we can calculate, right? You substitute 1 bar they have given is equal to, so P naught A, if you calculate already mole fraction they have given, first we will take this mole fraction. So 6.56 into 10 to the power minus 3. Okay, so you substitute here P naught A is equal to 1 bar divided by how much? 6.56 into 10 to the power minus 3 grams, right? So therefore, vapor pressure of pure ethane or pressure due to pure ethane will be 1 bar divided by 10 to the power minus 3. If you take on to the top, then it will be 10 to the power 3. So therefore 1 divided by 6.56. Okay, or it turns out to be how much? P naught A is equal to 152 bar per gram. Okay, so very simple. Now you substitute that. Okay, so if you want to calculate the partial pressure at another concentration, okay, so therefore PA is equal to P naught A, already we have calculated. So therefore 152, okay, bar per gram into, so how much it is? 5 into 10 to the power minus 2. So if you do that, so it turns out to be how much? So 0, 1, 20, 6 to 760. So therefore, if you substitute, so it comes around 7.6 bar will be the pressure at concentration. How much? 5.0 into 10 to the power minus 2. Okay, so that is how you are supposed to calculate this problem, right? So next we will move on to the next another. Okay, let us look into this problem. Henry's law constant for the molality of methane in benzene at 298 Kelvin is 4.27 into 10 to the power 5 mmHg. Okay, calculate the solubility of methane in benzene. Okay, so in benzene at 298 Kelvin under 760 mmHg pressure. Okay, so we will see this one, right? So there is a benzene. Okay, and he wants to dissolve methane gas, right? So to dissolve methane gas, right, Henry's constant is given and he is applying 760 mmHg pressure. Okay, how much methane is going to be solubilized in benzene? So that is being asked. Okay, or mole fraction of the methane in benzene. So that we are expected to calculate from this, and given quantities are what? So that is KH, Henry's constant is given 4.27 into 10 to the power 5 mm Hg, and your P, partial pressure, okay, of methane, it is given, that is 760 mm Hg, and now we were expected to calculate the mole fraction of methane in the given solution. Okay, so how much amount of the methane is being dissolved, right? So that we will see. So we know that what is the formula? P of methane is equal to, how we can write, KH into mole fraction of methane, right? So therefore P is how much? 760 mmHg divided by KH is how much? So it turns out to be 4.27 into 10 to the power 5. Okay, MMHG will get cancelled. Okay, so then what you will be getting? So that is your whole fraction of methane. So X methane is equal to, so 177.58 into, if you take on to the top, it turns out to be 10 to the power minus 5. Okay, so this much amount of methane is going to solubilize, right? The amount of methane dissolved or mole fraction of methane is 177, or you can make it like this, 1.78 into 10 to the power minus 3. Okay, so this is what is the answer, right? So this is how we have gone through the problems on percentage of mass and percentage of volume, then molality. Okay, so then ppm also one problem we have seen, and apart from that on Henry's law we have taken one problem, and Raoults law also, right? So in the next upcoming video, so see whatever the problems I have taken, it is like you have to solve such say similar type of problems. Okay, and definitely we'll be getting one question from this for 3 marks. And next part is colligative property. Okay, on that also we will be having one numerical problem, total 2 numerical problems, one from this particular part what I have discussed in this particular video, and another will be the on colligative property that we will see in the upcoming video. Please don't forget to subscribe our channel and continue watching till your examination to achieve the goal of mission 70. Thank you for watching.